Welcome to my latest video on how to download and install vSphere integrated containers. I'm going to take you through everything that you need to know to install a VIC to your vSphere cluster and what it is and what it does. So hopefully we'll get all that in around 20 minutes. So the very first thing you need to know is where do I find information on VIC and how do I download it? Now the place that I would start is vmware.github.io/VIC product because it gives you a little bit of information, but critically it gives you the important links that you need. So if we click on download here, for example, and right click on the download link, it will take you to my VMware where you can basically download the OVA. Now I'll start that going now. Now you'll notice that previous versions of VIC shipped as separate downloads. Now VIC 1.1.1, everything is bundled together in the OVA. That's the registry, the management UI, and the engine, and you'll see all of those in detail when we come to install them. Now other useful information that's linked off of here, you can link to the documentation, which is here, which we'll be looking at a little bit later on. It also links to how to get in touch with us. Now you'll see there's various different Slack channels here. So I can open the VIC product Slack channel, and this is monitored. We engage with people on this Slack channel. I haven't in a while, I'll be quite honest, but we do. And the other thing that you'll find is the link to our actual code, because everything that we do is an open source, so you can link to our VIC engine GitHub repo, and you can raise issues in here as well if you really want to. If you find problems, we really want to hear from you. Just click on issues here and new issue and tell us what's wrong. As you can see, I literally just raised an issue about the fact that the link to our docs is wrong in the github.io page. So there you go, showing a shining example of how to raise an issue. So let's look at the vSphere infrastructure that I'm going to be installing my OVA to. As you can see, I have a cluster right here. Now this cluster is configured with DRS and vSAN enabled. I have 3 hosts in that cluster, and this is where I'm going to be deploying my OVA to. Now, as I mentioned, the OVA has the management UI, it has the registry, and it has the potential to install virtual container hosts. Now, we'll get on to more detail about virtual container hosts a little bit later, but suffice to say that a virtual container host is a Docker endpoint for a tenant, right? So as an admin, you install a virtual container host to give somebody the ability to provision Docker containers to this vSphere infrastructure. So I have a cluster of 3 hosts. I have a few local data stores, but I also have an iSCSI data store and a vSAN data store. In terms of networking, I have a distributed virtual switch with a few different port groups added, and this external network is the network that I get to the outside world on. So that's a quick summary of my infrastructure. So let's go ahead and install the OVA now that it's downloaded. So I need to select it. So let's select this one here. Okay, so I'm going to need to call it something. So I'm going to call it VIC 1.1.1 OVA. Next. Okay, so I want to tell it where to install. Okay, all right. So, yep, we're all good with that. Accept that. Okay, so what data store do I want to install this to? I'm going to install it to my vSAN data store. So the disks it's creating here are mostly going to be used by the image registry for storing your container images. So the network, I'm going to use my external network for networking. Okay, so I'm going to cut and paste my password just to keep things simple. So this is the root password for the appliance. Now we need to set IP addresses and network config for the OVA. So that's my static IP address. Now I'm going to set it up with static IP addresses, because that's probably what most of you are going to do. So I'm going to do that too. So 254.0, but you can use DHCP just by leaving all of this blank if that's what you want to do. Okay, so the gateway, I need to cut and paste from here. Domain name server IP addresses is going to be, okay. Now, an important point about the DNS servers, they are space separated, not comma separated. I made that mistake once, and it was an unpleasant user experience because it caused some undefined behavior, which I then raised a bug about. But just bear in mind, space separated, not comma separated. Domain search path, eng.vmware.com. And the qualified domain name of this is bcori test 11. Okay, so those are my network settings. They look correct. So now I'm going to go down and I'm going to set the password for the admin account on the registry and the password for the database. I'm using the same password for everything, as you can see. I'm going to hit the garbage collection button so that if when the registry boots up, it does a bit of cleanup. Now, that's pretty much all you need to set. You can provide certificates for the management portal and the file server that gives you the Vic Engine installer. We don't really need to do any of those things. In fact, you can do the same thing for the registry as well. I'm just going to go with the default certificates. I'm happy with all those settings, so let's go to next and then finish. So now it's going to install the OVA, and let's take a pause and fast forward to when the OVA is installed and powered on. Okay, so the OVA has now successfully installed and I've powered it on. And the next thing we need to know is, how do I access the services that are running in this OVA? So let's click on the console. You can see it there. It's basically telling us that we have a management portal at port 8282. So that's the next place that we're going to go. So we click on here and type in that IP address. Okay. And good. So we now have a window where we have two capabilities. We have the management portal and we have the registry. And the registry should load. Now the admin user ID, the password that we set previously. Okay, so this is the registry that comes with Vic. And again, we'll be looking at this a little bit more later. So the registry, the management portal, again, we'll look at that a little bit later. But the next thing to do is actually install a virtual container host, right, which is a Docker compatible endpoint that someone can connect to. Now, the way that we do that is a little bit obtuse. In fact, it kind of forces you to go and look at the documentation to figure out how to do that, which is good and bad depending on how you look at it. So let's look at the documentation. vSphere administrators. Now, what it'll tell you is, if we go deploy a VCH to a basic vCenter server cluster, it will tell you there is a magic port 9443. And so if we go to here, we put our IP address in 9443, you will see a file server. A file server. Now, the file server has the plugins that you can install for the UI, and it has Vic Machine, which is the tool that you use to actually install endpoints. So what we're going to do is we're going to copy the link address of that and go to a console. Okay, so this is a previous install. Okay, so this is empty now. What we're going to do is we're going to basically download this using curl. And I'm cheating here. I'm showing you the magic command line to do that. Basically, as you can see, I've used that 9443 port and that file server IP address. We've piped it into tar, and we now have Vic Engine. So if we type Vic Machine Linux. As you can see, it ships for Linux, Windows, and OS X. Now you'll see Vic Machine is the lifecycle manager for virtual container hosts. Create, delete, inspect, upgrade. It basically allows you to do anything with a virtual container host. So this is a great point for us to describe what a virtual container host is in detail. Well, as a vSphere admin, it gives you the capability to create a secure area for a tenant to deploy workloads into. So a virtual container host is the functional equivalent of a regular container host in that it is a container namespace. It has some resource constraints around it. It has some networking associated with it. It has some storage associated with it. But in this particular case, because it's virtual, it's not a VM, right? The container host we're deploying isn't a VM running Docker. It's in fact a resource pool in a vSphere cluster. And the networks are vSphere networks, and the storage is vSphere storage, and the things that the tenants will deploy are VMs, okay? So in other words, it's a self-service portal that you can set up with a certain amount of networking, a certain amount of storage, a certain amount of compute that a tenant can then securely access and self-provision into. So if we do, I hope that wasn't too confusing. There's plenty that you can read up about virtual container hosts. But if we do Vic Machine Linux create -- help, it's a little bit difficult to visually parse all the options that you can put into it. But very simply, it is compute, networking, storage, and some user. Okay, we'll go into detail on each of those things as we go. But let's just remind ourselves of the vSphere infrastructure that I'm going to be deploying this virtual container host to. I have the OVA deployed. I have my cluster. Remember, I have various different types of data store, and I have this distributed virtual switch that has some port groups in that are ephemeral port groups, and then this external network here. Now, the thing I didn't show you earlier is I've also created a user. If we go to administration, go to users and groups, you'll see I've created a user called tenant1. Now, tenant1 is going to be the vSphere user that is associated with this virtual container host. Now, the way to think about this is that a virtual container host is basically a Docker API facade on the vSphere API, which means you can control vSphere infrastructure from a Docker client. But in order for that to work without having to give the tenant any of your credentials, we basically assign a proxy user. Okay, so that everything that the tenant does using a Docker client gets translated into a vSphere API command, which is then executed by this particular user, in this particular case, tenant1. And of course, we don't want to. We want to be able to lock down and limit the capabilities and the role that tenant has. So the documentation has a lot of detail about how to create the VicOps users group, which will limit what the various VCH users can do. So if we go back to the documentation and we look at the information for vSphere admins, and if we go to advanced examples of deploying a VCH, we go to different user accounts and then click on this link here, you'll see it goes into quite a lot of detail about all the roles that you can create in vCenter. This is a video in itself, really. I'm not going to go into any detail about this, but this is where you find it in the documentation, and that's how you can ensure that the user that I just showed you, the tenant1 user, can only do very, very limited and specific things. So having reviewed the infrastructure that we're going to deploy the virtual container host to, let's actually see how to use Vic Machine to achieve that goal. I'm going to take you through each of these options from the top to bottom, and we'll make some mistakes and use first principles to get there. So first thing to do is type Vic Machine Linux create, and the first option you'll see at the top there is -- target. Now the target is the vSphere IP address or domain name. That is our target, the VC target. The next thing is a user. Now this is the user that's going to be used by vSphere to actually install the virtual container host. In this particular case, I'm going to use administrator user because I am an administrator. This is a different user to the user I showed you earlier, which is the proxy user that's used by the virtual container host itself. We specify that by using --ops user. And remember, we had tenant 1 at vSphere.local. And that is going to be the proxy user the VCH uses to create VMs and all those other kinds of things. So next thing is name. --name. I'm going to call it T1VCH. You'll see we skipped over thumbprint there. We'll actually derive that by not entering the thumbprint. That's in fact the easiest way to find it. Compute resource is the next thing. Compute resource. So that's the place that I'm going to install this virtual container host to. Now, this could be a vSphere cluster. It could be an ESX host. It can be a resource pool. In this particular case, I'm going to make it a resource pool, partly because the resource pool allows us to limit the permissions. We can assign the group that we created earlier to this resource pool. So if I call this T1 VCH RP, okay, that will create the resource pool. Now, if you see, we have VicOps users group added to this entire cluster, and this has inherited that permission. So that's all good and fine. So we're going to specify the compute resource as T1 VCH RP. So the next thing we're going to specify is image store. So what is image store? Well, as I mentioned, your Docker images exist in your container registry, but when you pull them to create a container, they're downloaded and turned into VMDKs that live on the data store. We'll see an example of that later. So where do we want these Docker images to live? Which data store? Well, again, let's have a look at the data stores we have available. I'm going to use the iSCSI data store, this particular NVMe one. So I'm going to type iSCSI NVMe. Now, it's much better if this data store is a shared data store, because then DRS can move these VMs around anywhere and they'll still be able to see the images that they're connected to. So that's the image data store. So let's keep working our way down. The volume store. So volume store is the data store where volumes are stored, and you can specify more than one of these. For fun, let's use the vSAN data store as our volume data store. Now you can specify a label as well, so that you can choose from the Docker client which data store to deploy to. Default means that any Docker volume create is going to deploy by default to that data store. Now, if you want to, you can actually specify the container ephemeral state on a different data store, but we're going to skip over that right now. So, bridge network. So the bridge network is going to be the private network that these containers are going to be able to talk to each other on. So if we go and look at our networks, I actually created, let's just delete this and recreate it just to show you how to do it. If we go to here, this distributed virtual switch, and create a new distributed port group, and I'm going to call it T1 PG. Actually, no, let's call it T1 bridge. That's a little bit clearer. And I'm going to create, I'm going to use ephemeral binding, finish. Okay, so there's T1 bridge. So let's go back to here. T1 bridge is going to be my bridge network. Now the external network, actually the public network is external network, which you'll see is here. This is the same external network that I used for the OVA. So that's how we're going to be able to get to the outside world to download things from Docker Hub and that kind of thing. Management network is if you want the vSphere traffic isolated on a particular management network, you can do that. Container network, I'm actually going to use that because that's quite useful. Now, container network allows you to take any vSphere port group and expose it as a network to the Docker client. So you can do Docker network ls, and you'll see the port group, and you can do Docker When you do Docker run, you can do --net and specify it and connect a container workload directly to that port group. And again, I'll show you an example of that later. So container network, I'm going to use the external network for a container network. Okay, so we've got enough options here to actually just give it a go and see what it complains about. It's going to ask for both passwords. Okay, so it's not happy. What is it not happy about? Well, by default, it wants to create a secure endpoint. And to do that, it uses TLS authentication, and it will create a certificate for you in order to help you do that. Now, you can choose to not do any of that by using --no--TLS, but since you're almost certainly going to want to do that, let's run through an example of how. So very simply, we just need to add TLS-cname, and then in my case, star.eng.vmware.com. Okay, so it will now generate the certificates necessary for a client to authenticate with that endpoint. Okay, so it's not happy about one last thing, which is the fact that we didn't specify the thumbprint. So let's add that. Now, if I've got the passwords right, it should now install, which it's doing. Excellent. So it's going through a few different stages. It's checking the firewall status on each of these hosts. Now, note that I didn't show you this, but one prerequisite that you have to do is to enable an open port on the firewall of each ESX host in the cluster. Now, there is actually, if we do Vic machine Linux update and then firewall, that's an easy way to do it. It will automatically configure your ESX hosts for you. Go and read the documentation for how to do that. I'm not going to cover that right now, but this is installed successfully, which is excellent. So let's go and have a look at what it looks like. If we go back to our cluster, okay, this is the installed VCH. Now it's installed in the resource pool we asked it to. It's installed what looks like a VApp, and all the containers that are created are going to be installed underneath as children of this VApp. And then this VM that's been deployed is the VM that contains the Docker compatible API that we just secured with TLS authentication, and that's what we can now connect to with our Docker client. So one of the useful things that Vic Machine tells you is the environment variables you need to set in order to connect. So if we do export and do Docker info, hooray! We're now connected to our vSphere integrated containers engine endpoint. Now let's just pause for a second and think about the roles here. As an admin, you just use your vSphere credentials, your access to vCenter, and everything to create this endpoint that you are then going to hand off to a user. So what do you need to give to the user? Well, you need to give them these environment variables, and you need to give them the certificates. And the certificates in this case are created in a subdirectory of the same name as the virtual container host. There's the certificate. So if you just tar those up and pass on those environment variables, those are the only things you need to connect to this remote Docker endpoint. So what can I do with this Docker endpoint now? Let's have some fun. So if I do Docker network ls, there we go. I can see the vSphere network that we specified originally, and the bridge network there is the bridge network that we specified. If I do Docker volume create, that will create interesting. That will create a new volume. I know why that volume is there, but let's not go into that. That will create a disk on the volume data store that we specified, and I can attach that now to a container workload. So let's actually combine these things and run a container. So if I do Docker run -v, let's create foo2. Let's mount foo2 at I don't know, let's call it foo, that's fine. Let's call it data, just to not be obscure. --net equals external network. So that will actually now, when this runs, it will have a VNIC directly attached to external network, and it will get an IP address on external network. And if you don't specify that, it would attach to the bridge network instead. -it will give me a shell into the container that's going to start up. And let's use Debian. So this is now pulling down the Debian image from Docker Hub onto my data store, the iSCSI NVMe data store that I specified where images should go. And once it's finished extracting those images, it will create a brand new VM that's on that external network that has this disk mounted to it in addition to the images that have been created, and it will give me a shell into the VM that comes up. And there we go. So this is a brand new VM. If we actually go and look in vSphere, you'll see there it is, Fervent Jennings. It's powered on. Now, how can I tell that this is a VM and not a container? Well, if I do ps-ef, you'll see that I can see all of the processes running inside this VM. I'm not in a C group. I'm not in a process namespace. I've run a Docker image as a VM, but the VM looks and feels and smells just like a container. If I go to my data volume, you'll see there's my data volume. Okay, so I've created some data on that volume. Now, if I exit this VM, if I exit the container, VM, it's basically the same thing. That will power off, and it's just waiting for the power off to complete. Now, if I do docker ps-a, you'll see there's the container ID. If I do docker, in fact, if we look, you'll see that it's powered off. If we do docker rm 9ce, that will delete that VM. See, it's gone. And then, if we do docker volume ls, the volumes are still there. So that persistent data is still there. So in summary, I'm now controlling vSphere from a Docker client without any vSphere credentials, but within the sandbox that's been created. So let's just end by looking at a couple of other Vic machine commands that we can use. So ls, for example, lists the virtual container hosts that are available. You can see that one there. And for each of these Vic machine commands, it takes a subset of options. So if we want to do delete, for example, we just specify the name, user, thumbprint, put the password in. It was not happy with that. We need to specify compute resource, okay? Compute resource, and that's, what is it? T1 VCHRP. Vic Machine is pretty helpful at telling you what it is that you've forgotten or what's missing. We are working on a way to make it more user-friendly because, quite honestly, all these options can get a little bit out of hand at some point. Now, it's noted that it didn't delete the volumes because if you want to delete volumes, you need to specify -- force. But anyway, we've now deleted our virtual container host. You can see, you can see this resource pool is now empty. So, in summary, we've shown you how to download the OVA, how to install the OVA, how to get into it, and how to install virtual container hosts. Now, the next video I need to do is to show you how to use the management UI, how to use the registry, how to tie all this stuff together. But I'm sure you've had quite enough of me yammering on for one day, so I'm going to end it here. Thank you.